Find the complete solution or show that the system is inconsistent. X plus y minus z equals 0, x plus 2y minus 3z equals negative 3, and 2x plus 3y minus 4z equals negative 3. We use the first and the second equation to get rid of the term x in the second equation by subtracting the two equations. We take equation 1 minus equation 2. This is the same as taking equation 1 plus negative 1 times equation 2. We get x plus y minus z equals 0, x plus 2y minus 3z equals negative 3, and we subtract the 2. X minus x is 0x, y minus 2y is negative y, and negative z minus negative 3z is negative z plus 3z, which is 2z, and 0 minus negative 3 is positive 3. So we have the equation y minus 2z equals negative 3. This will be one equation in an equivalent system. We can also multiply negative 2 to the first equation and add to equation 3. If we take negative 2 and multiply every single term in the first equation, we would obtain negative 2x minus 2y plus 2z equals 0 times negative 2 is still 0. And we add this to the third equation, 2x plus 3y minus 4z equals negative 3. Negative 2x plus 2x is gone. Negative 2y plus 3y is positive y. 2z plus negative 4z is negative 2z. And 0 plus negative 3 is negative 3. We now have a new equivalent system. We keep the first equation, x plus y minus z equals 0. The second equation is now y minus 2z equals negative 3. And the third equation is y minus 2z equals negative 3. And again, the second equation comes from the first and the second. The third equation comes from the first and the third equation. Observe that the second equation and the third equation are the same. So we take the second equation and we subtract the third equation to obtain an equivalent system of equation. X plus y minus z equals 0. Y minus 2z equals negative 3. And 0 equals 0. Y minus y is 0. Negative 2z minus negative 2z is 0. Negative 3 minus negative 3 is 0. When we obtain a true statement such that 0 equals 0, this means there are infinitely many solutions. And if there are infinite many solutions, then we say that the system is dependent. And if the system is dependent, we would let the free variable, which is in this case 0z, think of it as the third equation, 0z equals 0, which means z can be any real number. So we let z equal t, where t is any real number. T is the parameter in this case. Then we do a back substitution. If z equal t, then y is 2t minus 3. We simply substitute z with t, so y minus 2t equals negative 3 is y equal to t minus 3. And then we perform a back substitution where we use the first equation, x plus y is now 2t minus 3, and z is t, and we isolate x in terms of t. This is x plus 2t minus 3 minus t equals 0, and so x equals 2t minus t is positive t, but we move it to the other side. Negative 3, we move it to the other side. And so we end up with x equals negative t plus 3. The solution to the system of equations is therefore x equals negative t plus 3, y equals 2t minus 3, and z equals t, where t is any real numbers that satisfy these conditions. There are infinitely many real numbers that we can use. If we want to have a particular or specific solution, we simply plug in various values for t, such that t equals 0, t equals 1, t equals negative 3, t equals negative 1. For example, if t equals 0, then one of the infinitely many solutions is 3, because if we plug 0 into x, we have x equals 0 plus 3. So x is 3, y is negative 3, and z is 0. If we plug in 1, we have another solution. Negative 1 plus 3 is 2. 2 times 1 is 2. 2 minus 3 is negative 1. And z is 1, and so on. There are infinitely many solutions here. The system is dependent.